Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. A very good morning I bid to all of you, our beloved lecturer and panel. Now I will present about our project of IED, Integrated Engineering Design, which is in title of Automated Eco Slicer under Dr. Rosdiana. Next, meets our team, which is the first one, Ros Anis Farihan, and me, Anas bin Osman, and the last one is Nur Aini. Our content of this slide was the first one, defining problems and generate solution. Second one, selecting the best solution. The third one, developing product, and the last one, which is our conclusion. First of all, it is about the process of defining problems and generate solution. 1.1, meeting with the expert, dealer, or user. Puan Azida, who is live at the Kuala Pahang, which is near from our university, live with her beloved husband. They have been involved in this industry of keropok for almost 11 years up until now. Here, we will attach the link for more information about our meeting with Puan Azida. 1.2, meeting with the team members. Our group have a very good relationship with each other in completing our project. Therefore, we have done a few of meeting among us and make some discussion more about the project since before the MCO and up until now throughout the online video call and etc. Here also, we will attach a few of our meeting minutes and more about our discussion.
I'm Ros Anis Farihan. This is Fishbone Diagram for Problem. There is measurements, people, material, equipment, and environment. For the measurements, there is more power is needed for the slicer when dealing with heavy conditions and not efficient in the working area. For the people are not agree on the using slicer in neighborhood areas and very dangerous of dealing with children. For the material, inferior parts of the slicer is not an eco-friendly and also no experience handling the slicer. For example, there is no idea that slicer need to be monthly serviced. For the equipment, high maintenance, starter motor takes a while to turn on. For the environment, there is weather I need to be concerned. Never use the slicer during rain. This is fishbone diagram for solution. There is 6 solutions we have. For solution 1, there is more stability, high durability, complex measurement, elegant looks using the slicer system. And solution 2, there is more to portable, low physical strength needed for the user, using manual slicer, cheaper, easy to mount. For the solution 3, there is more to complex, feel, cutting speed, work in one place, and costly. For the solution 4, there is more to complex and small design, faster in working, depth of cut, easy to handle, safe to use for all age. For the solution 5, low in structure, easy to use, non-rechargeable, affordable, and low safeness. For the solution 6, very simple design, low in cost, static machine, low safeness, less efficiency. There is less time consuming, increased productivity, decrease the chance of not getting any accident when using the machine. There is process of selecting the best solution. This is weightage of requirement and criteria table. There is requirement and criteria. R1 automated function, R2 hygienic optimized to clean, R3 precision slicing machine, R4 efficiency in operating, C1 safety, C2 environment friendly, C3 ruggedness, C4 elegant, C5 aesthetic, and C6 cost effective, C7 easy maintenance. For the sixth solution, we choose one best solution. There is from solution 4. There is total mark with 32 total mark. For the solution 1, this is a requirement table for solution 1. The description that explain from R1, R2, R3, R4, R1, C2, C3, C4, C5, C6, and C7. This is a diagram of solution 1. For solution 2, this is also requirement table from R1, R2, R3, R4, C1, C2, C3, C4, C5, C6, C7. There is as well from description of this table. This is diagram for solution 2.
Slicer and robot arm. This machine is not fully automatic because the robot arm only pick up the broccoli from the container and put it on the conveyor of the slicer, and the slicer will slide it. But the worker need to remove it by themselves to the drying canvas or drying rack. For the component of this machine is hard to clean, then this machine work efficiently to cut the broccoli accordingly to the size that we want. This work machine only work in one place because of their size and their weight, and we found out that this machine may appear injury if worker not use properly attire by using this machine. This machine is eco-friendly and stubborn rejection. The design of the cutter slicer or the slicer show the elegance of this machine, and no personality is found. And the cost for this machine may be high because of the component and material used for develop this machine, and it is easy to maintenance. For solution number 4, we name as slicer and robot knife follower. From all of the 6 solutions that we proposed, solution number 4 is almost meet all of the requirement and criteria that we need. And this machine is almost fully automatic machine because this machine will cut the core for eco, and the robot line follower will move around the drying canvas to drop the core for eco on it. So worker no need to cut and put it on the drying rack. It is fully automatic and assembled by the robot itself. And this machine is easy to clean and carry because of their small size. And the deep cut of the slice material is more accurate and it's easy to handle and moderate. And it is eco-friendly, and the size of the machine is moderate. The slicer with the robot light follower is show the elegance of this machine, and this machine is quite moderate costly because it is small, and the component needed for this machine is also easy to maintain.
Thank you for my fellow friend. Now I will continue for the solution number 5. The description of this machine for the automated function, it is a very complex but small in design. For the hygienic, it is very easy to clean because the upper and the body is easy to be removed and easy to be cleaned. The precision slicing machine, it is easily to break because of the low material in making for the body. The efficiency in operating, it is easy to use, but the safety of the machine is in a moderate one. The environment friendly, it is a very eco-friendly, and robustness size of the machine is in a moderate. For the elegance look, it is a very low in structure. Next, the aesthetic, no constant beauty is found. For cost effective, it is an affordable machine for all the ages. And lastly, the maintenance, it is a very hard maintenance because the motor was inside the machine. For the next one, solution number 6. This machine is an automated chopping board pusher. The hygienic, it is a very easily to clean because this machine is a static one. The precision slicing machine is not to blend. The efficiency in operating, low in efficiency. The safety of this machine is in a very low safeness. The environment friendly, it is a very eco-friendly because we are using the rechargeable battery for this machine. Robustness, the size of the machine is low and ordinary, and it is easily to break. Elegance, no elegance found in this solution. Aesthetic, no aesthetic found in this solution. Cost effectiveness, it is the lowest price in creating the machine. The maintenance, it is very easy in maintenance because it is as it uses an electricity. Next one is the process of developing the product. 3.1 Proposed design. These are the 6 solutions that we have been proposed for the design. The idea number 1, robot static with the slicer. And idea number 2, manual slicer. Next, idea number 3, slicer with the arm. Idea number 4, slicer with robot line follower. And idea number 5, smart slicer. And the last one is idea number 6, automated chopping board pusher. Okay, for the next one, 3.2, which is about detail of the calculation. The first one, we will wait for the keropok leko with the formula of W is equals to mg, where m is equals to mass of the keropok and the g is equals to the gravitational constant, as we know, equals to 9.81 meter per second squared. The mass of each keropok is about 100 gram. Therefore, weight of the keropok leko is equals to W equals to 100 gram times with 9.81 meter per second squared. Therefore, we will get the value of the weight of the keropok leko, which is W is equals to 981 gram meter per second squared. Thus, we need to improve the stability of the line follower as it can be handled for the load very well. For the next one, we will calculate for the work done by our line follower. As we know, work done is equal to force times with the distance, which is along the line of the action. Therefore, the work done formula is equals to W is equal to F times with S, where F is equal to the resultant force and S is equal to the distance. Therefore, the resultant force is equals to F equals to ma, where m is equal to mass and a is equals to the acceleration. The acceleration, as we know, a is equals to v minus u over t, where v is the final velocity, u is the initial velocity, and t is the time taken for the line follower. Velocity formula is equals to v equals to s over t, where s is equal to distance and t is also equals to the time taken for the line follower. So that we will assume the distance tracked for the line follower on the canvas is equals to s equals to 7 meter. The time taken for the line follower Arduino robot to finish in one cycle, t is equals to 21 seconds. Therefore, the velocity, we will get v is equal to s over t, where else v equals to 7 meter over 21 seconds. Therefore, we should get v is equals to 0.333 meter per second. Next, the acceleration a is equals to v minus u over t, where a is equals to 0.3333 meter per second divided by 21 seconds, so that we will get a acceleration is equals to 0.0159 meter per second squared. The next one, we will find for the resultant force. F is equal to ma, where m is equals to 100 gram times with 0.0159 meter per second squared. Therefore, F resultant force is equals to 1.5873 gram meter per second squared. And last one, work done is equals to W is equal to Fs, where F is equal to 1.5873 times with 7 meter. And we should get work done is equals to 11.1111 gram meter squared per second squared. Okay, for the next one, we will calculate for the power. As we know, power is a rate at which work is done or energy is used. It is equal to the amount of the work done divided by the times it takes to do the work. The unit of power is the watt, and which is equal to a joule per second. Thus, the formula for the power is equals to P equals to work done W over the time taken, which is T. Therefore, P is equals to 11.1111 gram meter squared per second squared over 21 seconds. Therefore, we should get the value of the power, which is P is equals to 0.5291 gram meter squared over second cube. Okay.
This is a mechanical drawing. This is upper view, side view, and front view. This is S-plot drawing. This picture upper view, side view, and front view. All drawings we use in AutoCAD drawing.
The electrical part. For the electrical part circuit diagram for the robot car line follower, this is a diagram of the circuit that we build in Arduino Uno apps. The connection is shown as on the picture. This is the real connection for our Arduino line follower car. For the slicer, we just connect the motor and the battery, the positive side into the positive side and the negative side into the negative side. Then we start to develop our project by develop our slicer first. We build up the slicer part and attach all the components that we needed. We connect with the motor and the battery, and then we test it. If no problem occurs, we will proceed to develop our line follower robot car. We start to build our line follower robot car by attaching all the components that we needed. Then we program it using the PC code, and then we test. If no problem occurs, we will proceed with the next part, which is integration. We start to integrate the slicer and line follower robot car, and then we testing it. If any problem happens, we need to inspect it and testing it again. But if no problem happens, we call it as a success. So this is how our machine or system works. We start with turn on the robot and the slicer. Then the robot will move forward once they detect the line, and the slicer will start to spin. The worker will put the robot Lego into the container on the slicer, and the slicer will slide in, and the robot will move forward left or right according to the direction. When moving around, the robot Lego will drop the robot slice on the drawing canvas. If the container is empty, the buzzer will produce a beep sound to notice the worker to fill in the container. The process will continue and repeat the same thing until the robot Lego is full on the drawing canvas. This is four main components that needed to make the line follower robot car to be mentioned. The first one is sensor for the line detection. The second one is Arduino as a controller. The third one is motor driver, and the last one is motor for process motion.
Next, we will talk about the working of line follower car using Arduino process. As we know, we are using two IR sensor module, namely left sensor and right sensor. When both left and right sensor did not detect the black line, then the car will move forward freely. If right sensor detect the black line, then car will turning into the right side, where the right motor will be back forward in motion and the other one will move in the forward motion. Therefore, the robot will turning into the right side. It is a vice versa for the left sensor. If left sensor comes on the black line, then the car will turn into left side, where the left motor will move into the backward motion and the right one will move into the forward motion. Then the robot will turning into the left. And if both sensor comes on the black line, the car will automatically stop. Next, it is about the flowchart of line follower car using the Arduino. We will start it with the start. Then the IR sensor will detect the line. If both sensors detect the line, yes, automatically the robot will stop in moving. If no, sensor detect line junction. If right sensor detect line, yes, the car will turn into the right side. If no, the car will move forward. If the sensor detect the line junction of left one, yes, the car will turn into left side. If no, the car will move forward. Coding for Arduino line follower car. The first one, we defining pin and variable. Define left is equals to A0 and right is equals to A1. Defining motor, AFDC motor for motor number 1, 2, 3 and 4. Void setup, declaring pin type. Pin mode, left input, pin mode, right input. And the serial begin, which is 9600. Void loop, the serial pin, digital mode left, serial print learn, digital read right. Line detected by both. If the digital read left is equal to 0 and the digital read right is equal to 0, motor number 1, 2, 3 and 4 will automatically move forward with the speed of 150. If the line detect by left sensor, the digital left is equal to 0 and the digital right is equal to 0, and the robot will turn it into left, where the motor number 1 and number 2 will move forward, but motor number 3 and number 4 will move backward. Therefore, the robot will turn in. Next, line detected by the right sensor. If digital read left is equal to 0, digital read right is equal to 0, motor number 1 and number 2 will move backward, but motor number 3 and 4 will move forward. Therefore, the robot will turn into the right side. And lastly, line detected by none. If digital read left is equal to 0, digital read right is equal to 0, all the motor 1, 2 and 3 will release and stop in